what the mid and lower face tell us. Orbit shape. April Garwin teaches forensic anthropology, and her Lesson 6 deals with ancestry determination. She has a section called Summary of the Current Research Methodology, in which she says about eye orbit shape: Caucasoid, angular and sloping; Negroid, square or rectangular; Mongoloid, round and non-sloping. The skulls from Hellenistic period Judea were 14.8% round for males and 37.5% round for females, 77.8%, 27 skulls, square for males, and 56.3%, 16 skulls, for females. During the Roman period, both sexes, 64.3%, 14 skulls, have square orbits. According to this trait, the Judean population of En-Gedi had stronger sub-Saharan African affinities than Eurasian, to the tune of 66.1% to 33.8%. Prognathism. What is alveolar prognathism, and what is the relevance of it to geographical groups? April Garwin informs us that Caucasoids have a flat orthognathous face in the dental area along the midline. This is the opposite of the Negroid face, which exhibits protrusion of the mouth region, known as prognathism. Negroids are noted for alveolar prognathism, or an anterior protrusion of the mouth region. The next question is, to what degree does alveolar prognathism arise in the Judean population? Ahrensberg et al. Informs us that moderate to marked upper alveolar prognathism was not infrequent among En-Gedi males as well as in the Roman period crania. Ahrensberg, 1980b, page 285. Of the Judean Hellenistic period, males 54% had none slight prognathism, but 45.4% had moderate marked prognathism. This is in keeping with a mixed population of Afro-Euro type in roughly equal amounts. Bizygomatic breadth. The breadth of the face just beneath the eyes at the mid-ear plane is called the bizygomatic breadth. This measurement separates the European and African skull samples in the Howells database, as checked by the present author. It also goes a considerable way to separating cold-adapted, warm-located Asians from neighboring Negritos and Australo-Melanesians, although there is some overlap. Let us compare the bizygomatic breadths of African, European, and Judean skulls. In Table 8, we compare the population males, 30, with bizygomatic breadth. Norse, Norwegian, 134. Zalavar, Hungarian, 133. Berg, Austrian, 136.6. Poundbury, Roman Britain, 50, 136.4. Tieta, Kenya, 131.5. Dogon, West African, 129.4. Zulu, South African, 129.9. Kerma, Nubians, 52, 129.7. Lachish, Israel, 700 BC, 61, 129.7. Hellenistic Judean, 131.6. Roman Judean, 132.2. Safed, Galilee, 1500 BC, 7, 126. Safed, Roman Galilee, 14, 129. Poundbury and Lachish data from analysis of crania from Tel Dewar using multiple discriminant functions by SOY Chieta, AJPA 75, 1988, page 375 through 390. The Africans in the above table have lower bizygomatic breadths than the Europeans. In the samples, the lower European limit is 133, while the upper African limit is 131.5. The difference is approximately 1.5 millimeters. The Lachish Judah males have an average bizygomatic breadth that is identical to that of the Kerma Nubians. The 18th dynasty period male skulls from Safed are firmly within the African range. The Roman period Safed male skulls from Galilee are also within the African range. The Hellenistic period Judean males are far closer to the African range than they are to the European. The Roman period Judeans from El Gedi seem equidistant from Europeans and Africans. It is still possible to argue an Afro-Euro type population if the Afro-type population had an average of 126, like 18th dynasty Safed, and the Euro-type population had an average of 136.5, like the Berg Austrians. This interpretation would be consistent with most of the other evidence to date. Conclusion. The orbit shapes among the Judeans show a high frequency of orbit shapes associated with sub-Saharan Africans. The frequency of moderate marked alveolar prognathism amongst the Hellenistic and Roman Judeans strongly suggests a mixed Afro-Euro type population of equal blend, which became more Euro-type during the Roman period. Risden did not give percentages of the Lashish population that showed prognathism. The bizygomatic breadths of the Lashish population strongly suggest an Afro-type population. Those of the Judeans suggest a mixed population during the Hellenistic period, which became more Euro-type during the Roman period. The combined testimony of all three traits strongly suggests a mixed Afro-Euro type population. Chapter 6. What bumps and grooves on the skull tell us. The origins of skull discrete traits. Most people think of the skull as being one bone. Anyone who has ever held a skull will know that it is made of different parts. They are the frontal bone at the front of the skull, the occipital bone at the back, two parietal bones which take up most of the sides, two temporal bones, and two sphenoid bones. The universal bones are 8 in all. When you view the skull, all of these bones look like they have been sewn together. The stitch lines are called sutures. They can be simple lines or complex zigzagging lines. Sometimes smaller bones develop within sutures, but this depends on the individual. Skulls can also have grooves, markings, and depressions along the surface. The sutural bones and various markings of the skull are collectively called discrete or non-metric traits. We cannot measure them, but simply record whether a given discrete trait is present or not. They can tell us which part of the world a sample of skulls is likely to originate from. Two of the world's leading experts in these traits are the forensic anthropologists Berry and Berry. In 1967, they concluded that non-metric traits measure genetic heritage and population affiliation better than a collection of metric traits. Epigenic Variation in the Human Cranium by A. Carroll Berry and R. J. Berry in Journal of Anatomy 101, 2, 1967, page 377. Sutural complexity of ancient Jews and Africans. The human skull has a mixture of simple and complex sutural lines. Which ones are simple and which ones are complex appears to have a lot to do with geographical origin. Virginia Sutton, who had a master's degree in anthropology in the early 20th century, describes the relationship between geography and sutural complexity. In the skull of the Negro, the posterior lambdoidal suture is most complex. In the Caucasian, the frontal coronal suture, while in the Mongoloid it is the one along the midline of the skull, the sagittal. This is not an infallible indication. It is not at all uncommon to find individuals in whom the configuration of the sutures is at variance with the other racial indications of the skull. But for a long series, the information of the sutures will usually hold good as a racial criterion, and in determining race, the relative complexity of the sutures is ordinarily taken into consideration. The Sutures of the Mesa Verde Cliff Dwellers by Virginia Sutton. For Caucasians, we have been told the coronal suture is most complex, while the others are relatively simpler. For sub-Saharan Africans, the lambdoidal suture is most complex, while the others are relatively simple. We are also warned about considerable variation within geographical groups, something we have seen across every trait for which we have had the necessary data. It is the mean or average for a sample that can be used to suggest ancestry. In the light of this information, let us take a look at the non-metric traits of skulls from Judah to Judea. The skulls of Jews of the Hellenistic and Roman period from En-Gedi are described, in terms of their sutures, by forensic anthropologists as having serration in the coronal was predominantly simple, more so in female than in male crania. The sagittal suture, in contrast, was most frequently moderately complex. Although the most prevalent kind of serration in the lambdoidal suture was also moderately complex, a relatively high incidence of markedly complex saturation was here evident, 17% in the Hellenistic and 21% in the Roman period. Skeletal remains of Jews from the Hellenistic and Roman periods in Israel. Non-metric traits by M.S. Goldstein, B. Ahrensberg, and H. Nathan in Bulletin et Mémoire de la Société d'Anthropologie de Paris, 7, Series 13, 1980b, page 283 through 284. If we had to make a decision based solely on this, the dominant simple pattern in the coronal suture would appear to make Caucasian identity unlikely. We would have a choice between sub-Saharan Africans and East Asians. When we consider the distance of Judea from East Asia and sub-Saharan Africa, the latter becomes the clear favorite. The highest incidence of markedly complex was lambdoidal and not sagittal. This also supports African rather than Asiatic affinity. Thankfully, we do not have to make a decision based only on this trait. We have other data. Metopic suture. In the skull of a child, the two halves of the forehead, frontal bone, are connected by a suture that runs from the top of the nose to the top of the head, end of the frontal bone. It usually closes up completely by the age of 7, but sometimes it persists into adulthood. This is known as metopism. A metopic suture in adult skulls is rare enough amongst sub-Saharan Africans and East Asians for some commentators to claim it does not occur. We shall see this is not quite true. It is, however, common amongst Europeans and those of partial Eurotype ancestry in the zones of intermixing. In a study by A.C. Berry and A.J. Berry, Origins and Relationships of Ancient Egyptians in Journal of Human Evolution, Volume 1, 1972, of skull morphology between different populations, Enshanti showed 0 cases, but prehistoric Nubians showed 3.2 cases. Nakeda pre-dynastic Egyptian showed 6.6%. Lachish Israelite showed 7.4%, but medieval Edinburgh and Oslo showed 18% and 20% respectively. In a study by G.P. Reitmeyer on discrete traits, Right Time, 1972, the Sotho of South Africa had a metopism occurrence of 4.4%. Prehistoric Upper Egyptians and Iron Age Israelites were closer to the Sotho and prehistoric Nubians than they were to Northern Europeans in the frequency of metopism. Concerning the Judean skulls from En-Gedi, we are told, few crania of adults manifested the metopic suture. 2.3% of the males, none in the females of the En-Gedi material, and none in the Roman period crania. This finding is in sharp contrast to the relatively high frequency of metopism in Bedouin crania from Israel, 18% in males, 24% in females. Ahrensberg et al., 1980b, page 284. It would appear the modern Bedouin of Palestine are closer to European frequencies for this trait than the ancient Judeans. The ancient Judeans, however, appear to be more like sub-Saharan Africans than indigenous North Africans for this trait. Supraorbital notch versus foramen. The supraorbital region of the skull is approximately just beneath the eyebrow on a living person. On this region of the skull, 2 types of marks might occur, a notch or a foramen opening through which nerve or tissue goes through. Apparently, whether it is one or the other has climactic correlation. In cold climactic conditions, supraorbital foramina were found in the highest frequency, 35.4%. In warm and temperate climates, the observed frequency of supraorbital foramen were the lowest, 18.8% and 19.9% respectively. Frequency of supraorbital notches was the lowest of those skulls from a cold climate, 44%, and the highest in those from a warm climate, 59%. These results support the hypothesis that the occurrence of supraorbital notches is greater in populations from warm compared with cold regions. The localization of supraorbital notch and foramen is crucial for headache and supraorbital neuralgia, avoiding treatment by A. Tomachuska, Barbara Katakowski, and Ramontis Jankauskas in the Anatomical Record 295-9, 2012, page 1494. Skulls from warm and temperate climates have low incidences of supraorbital foramen at around 18 to 19%. In the Israelite remains from Lachish, we are told, the incidence of a supraorbital foramen in the Lachish crania, 17%, and in the modern Palestine group, 20.6%. Ahrensberg et al., 1980b, page 287 and 288. For the Lachish skulls, this is an even lower occurrence than what is expected for warm to temperate countries. For the modern Palestinian skulls, it was slightly higher. This associates the Israelite remains with warm adaptation. We would expect this from a population with affinities to sub-Saharan Africans. The Judean skulls from En-Gedi had right orbit notches at 76% and 79% in males and females respectively, well in excess of the 59% predicted for warm climates. Ahrensberg et al., 1980, page 283. Berry and Berry. In 1972, Berry and Berry published an extensive study comparing the discrete traits of populations from Africa, Europe, and Lachish. Below, we have combined the results with those of Reitmeyer, 1972, where the data is available, and shown the results. Highest nuchal line present. Medieval Scotland, 36%. Norway Oslo, 67%. Pre-dynastic Egypt, 16.2%. Prehistoric Nubia, 13.3%. Ashanti, 3.6%. Lachish, 16.7%. Conclusion. Frequency of Lachish skulls is closest to pre-dynastic Upper Egyptians and Nubians. They are most distant from Northern Europeans. Lambdoidal ossicle present. Medieval Scotland, 47.5%. Norway Oslo, 40%. Prehistoric Nubia, 44.6%. Ashanti, 25.9%. Pre-dynastic Egypt, 31.6%. Lachish, 29.8%. Conclusion. Frequency of this trait in Lachish skulls is closest to pre-dynastic Upper Egyptians and Ashanti. They are most distant from prehistoric Nubians and Northern Europeans. The prehistoric Nubians are, interestingly, closer to the Northern Europeans for this trait. Parietal foramen present. Norway Oslo, 64%. Medieval Scotland, 52%. Sotho, 56.7%. Zulu, 68%. Rwanda, 65.5%. Ashanti, 59.2%. Prehistoric Nubia, 56.9%. Pre-dynastic Egypt, 53.2%. Lachish, 35%. Conclusion. Frequency of this trait in Lachish skulls is different from every other group sample. They are closest to medieval Scotland and pre-dynastic Upper Egyptians, but at a great distance. They are most distant from Zulu and Tutsi Rwandans. Metopism. Norway Oslo, 20%. Medieval Scotland, 18%. Ashanti, 0%. Sotho, 4.4%. Zulu, 2%. Rwanda, 0%. Prehistoric Nubia, 3.2%. Pre-dynastic Egypt, 6.6%. Lachish, 7.4%. Conclusion. Frequency of this trait in Lachish skulls is closest to pre-dynastic Upper Egyptians and Sotho-South Africans. It is most distant from Europeans. Epipteric bone present. Medieval Scotland, 18.5%. Norway Oslo 18%, Prehistoric Nubia 14.9%, Sotho 8.1%, Zulu 6.1%, Rwanda 8.2%, Ashanti 6.2%, Pre-dynastic Egyptian 6.7%, Lashish 9.5%. Conclusion. Frequency of this trait in Lashish skulls is closest to Sotho South Africans and Tutsi Rwandans. They are most different from Northern Europeans. Frontal temporal articulation. Prehistoric Nubia 13.2%, Ashanti 9.8%, Medieval Scotland 0%, Pre-dynastic Egyptians 1.1%, Norway Oslo 1%, Lashish 0.9%. Conclusion. Frequency of this trait in the Lashish skulls is closest to Norwegians and pre-dynastic Upper Egyptians. It is most different from prehistoric Nubians and Ashanti. Parietal notch bone present. Norway Oslo 12%, pre-dynastic Egyptians 8.3%, Medieval Scotland 8%, Sotho 12.2%, Zulu 12%, Rwanda 9%, Ashanti 6.2%, Prehistoric Nubians 0%, Lashish 2.8%. Conclusion. Frequency of this trait in Lashish skulls closest to prehistoric Nubians and Ashanti. It is most different from Sotho South Africans, Zulu, and Norwegians. Zygomatico-facial foramen. Norway Oslo 9%, Medieval Scotland 13.4%, Pre-dynastic Egyptians 16.7%, Ashanti 18.7%, Sotho 80%, Zulu 84%, Rwanda 80.3%, Prehistoric Nubia 40.5%, Lashish 30%. Conclusion. Frequency of this trait in Lashish skulls closest to prehistoric Nubians and Ashanti. It is most different from Zulu, Sotho, and Tutsi Rwandan. Supraorbital foramen. Medieval Scotland 25%, Norway Oslo 21%, Sotho 28.9%, Zulu 21%, Rwanda 33.6%, Prehistoric Nubians 10.6%, Ashanti 11.7%, Pre-dynastic Egypt 11.8%, Lashish 13.6%. Conclusion. Frequency of this trait in Lashish skulls closest to pre-dynastic Upper Egyptians and Ashanti. It is most different from Rwandan Tutsi and Sotho. Results contradict the predictions of Tomaszewska et al. 2012. Anterior ethmoid foramen. Norway Oslo 29.3%, Medieval Scotland 18.4%, Pre-dynastic Egyptians 17.3%, Ashanti 15.4%, Sotho 1.2%, Zulu 5.1%, Rwanda 2.5%, Prehistoric Nubians 8%, Lashish 7.7%. Conclusion. Frequency of this trait in Lashish skulls is closest to prehistoric Nubians and Zulu. It is most different from Northern Europeans. The following table lists African closest to and African furthest to. African closest to, nuchal line, lambdoidal ossicle, metopism, epipteric bone, parietal notch bone, zygomatico-facial foramen, supraorbital foramen, anterior ethmoid foramen. African furthest to, frontal temporal articulation, zygomatico-facial foramen, supraorbital foramen, parietal foramen. The next table lists European furthest to and European presence in furthest to. European furthest to, highest nuchal line, metopism, epipteric bone, anterior ethmoid foramen. European presence in furthest to, lambdoidal ossicle, parietal notch bone. Of the 9 tabled results of headed discrete traits, 6 compare 6 African samples to 2 European samples, while 3 compare 3 African samples to 2 European ones. There is also high variability in the frequencies of the traits amongst Africans. We can therefore expect African bias in terms of presence in both the closest to and furthest to in relation to the Lashish sample. Instead, what we find is a clear African bias in closest to in contrast to furthest to. We also find a clear European bias in furthest to in contrast to closest to. There are no European closest to examples. The greater number of African samples has not prevented clear patterns of distance in relation to the Lashish sample from emerging. Lashish can only be classed as being closer to the Africans than the Europeans. Conclusion. The sutural complexity of Judean skulls suggests an affinity with sub-Saharan Africans. The frequency of supraorbital notches suggests a very warm-adapted affinity. The supraorbital foramen frequency suggests sub-Saharan African affinity. Judean skulls on this evidence are warm-adapted and have sub-Saharan and Saharan African affinity. The Lashish skulls also show sub-Saharan and Saharan African affinities more than European ones. For the frequency of highest nuchal line present, Lashish skulls are closest to pre-dynastic Upper Egyptians and Nubians. For the frequency of lambdoidal ossicle present, Lashish skulls are closest to pre-dynastic Upper Egyptians and Ashanti. For the parietal foramen trait, Lashish skulls are closest to medieval Scottish and pre-dynastic Upper Egyptian. For the frequency of metopism, Lashish skulls are closest to pre-dynastic Upper Egyptians and Sotho South Africans. For the frequency of epipteric bone present, Lashish skulls are closest to Sotho South Africans and Tutsi Rwandans. For the frequency of frontal temporal articulation, Lashish skulls are closest to Norwegians and pre-dynastic Upper Egyptians. For the frequency of parietal notch bone present, the Lashish skulls are closest to prehistoric Nubians and Ashanti. For the frequency of zygomaticofacial foramen, Lashish skulls are closest to prehistoric Nubians and Ashanti. For the frequency of supraorbital foramen, Lashish skulls are closest to pre-dynastic Upper Egyptians and Ashanti. For the frequency of anterior ethmoid foramen, Lashish skulls are closest to prehistoric Nubians and Zulu. There is considerable overlap for individual traits, but the combined evidence makes a clear statement. Europeans are never the closest to, but are the furthest to 4 times. Little else need be said to stress the African association of Lashish discrete skull traits.